again, the reason we don't want this is that the carbon monoxide then might enter the living space. Is that the reason?
Right. So I can actually, and
It has nothing to do with the moisture around the outside of the building or anything like that.
no, this is a combustion. We're testing combustion safety, and especially for an open draft water heater. Now, if that water heater wasn't your standard open draft water heater, but it was a high efficiency direct vent water heater that brings its own air in from the outside for combustion, and then puts the exhaust air back outside, you have different parameters. For that, they don't even want you to think there could potentially be a problem until you're at minus 15 pascals. So and you could actually take a standard one, and if you can adopt that to be a power assist draft unit, you could also get to the minus 15 pascals.
By the return ducts, I mean the ducts that distribute the heated air.
When I said, yeah, we have a big hole, I've created, through pulling this open, a large hole in the return air duct system of the house. So, yeah, every forced air heating system has supply ducts that take the hot air and deliver that around the house. And then they have return air ducts, which collect air and bring it back to the furnace. And so this has what we've simulated is large leaks on your return air. And that, even though we've simulated that here by pulling this open, that's actually the typical scenario in your basic house. Because you think about, if you look at that ductwork that is coming down to where your air filter is on your furnace, that's your return air ductwork. Oftentimes that's not taped. The enclosure where your filter goes may not actually be the best fitting in the world. If it's an old plenum that's been reconfigured for new ductwork, oftentimes that hasn't been fitted all that well. And frankly, it's typically a storage area, and people have banged and bumped into it a whole lot over the years as well. It's just a very high likely scenario that you have a leaky return air ductwork system in your house.
So if that's just supplying air to the furnace, why does it matter if it's coming through vents or through leaks?
Well, for air quality, you might not want to be sucking the air out of your basement or garage. That's a separate issue. We're talking about what this is doing is, instead of pulling air from the part of the house where it was supposed to pull the air, instead it's pulling it out of this basement where we have our water heater. So it depressurized the basement and could end up causing the exhaust to actually come down into the basement instead of getting out of the house.
Okay.
That's your problem.
So the only way to seal that would be similar to like sealing your heat supply. You'd have to tape off, because typically it's like the framers, it's like the heating conductor will go off and enclose like the bay of a joy system or your stud cavities or your colder returns in modern construction. Is that taping off?
Taping actually is not the preferred method. The preferred method is actually to use mastic on all your ductwork. And if you're building a new home to some green building certification or even just Energy Star certification standard, you actually need to mastic using a paste, water-based paste. You need to mastic all your seams.
So you put the mastic on the joist first, and then he would install the sheet metal to the bottom
No, actually,
of the joist?
when you see metal just nailed up to the bottom of joists, that actually is illegal to do anymore. That was done in the old days when they were first installing forced air systems, but you are not allowed to have your ductwork be made of wood anymore, because that's not a good idea. Moisture, dirt collecting on the surface of wood, that makes things grow. You don't want that to be what your ductwork is.
I don't know
So
how
basically, anytime you have a panned-off joist system that's available, and you can basically not seal them anyway. You really should be looking into replacing that with an actual ducted system.
But aren't most new homes built in the 90s or early, like stud cavities, where most of your cold air returns?
No, they actually have ductwork in the cavities. They don't use. People haven't used panned off. You know, by code, you haven't been able to use a panned off joist bay since, I don't even know. probably sometime in the early 70s or something like that.
Yeah, but you'd also
So-
be surprised too how many you'll still see even in newer construction in spite of that.
It's there. Yeah.
Yeah.
I was building homes in the Midwest, and we do it all the
Yeah.
time. Not that I.
Right, code around here, you
Yeah.
absolutely.
That's all I was just referring to. I've never
Yeah.
seen code returns totally created like a hot return.
Yeah.
Just a
It's-
cavity. Okay.
The ASHRAE standard.
Dave, we're assuming that ducts are in conditioned space right now, or you consider
We're
that-
not even talking about whether the space is conditioned or not.
Okay.
We're just talking about within this envelope. So we're not talking about conditioned space, we're just talking about airflow right now. We have no stack effect, which being conditioned space or not might be affecting that. As we said at the beginning, if this was a real home, we probably would have started already negative down here just because of the stack effect, but we didn't have that as a beginning point. So I can do a little visual for you here with some smoke in the water heater to actually show you. So this is what we're talking about, that instead of the smoke going up the chimney, it's actually just being sucked out into the space all around it.
Good thing you got a fan there.
Yeah, versus if you had a direct vent unit, that same smoke should be able to escape out top eventually. Although I may have such a depressurization going on that I'm not going to be able to get it out the top.
Escaping.
Yeah. But that's just a visual effect to help you understand. That's the problem that we're talking about with worst case combustion scenarios. And they aren't just, let me turn everything off for a second so we're at a baseline condition. You know, oftentimes a water heater in a basement is the typical problem. Because oftentimes somebody has had an old furnace and an old water heater. They replace the furnace with the new high efficiency furnace that brings in its own combustion air, exhausts it out. It's great. You know, you're talking about going from 80% efficient to maybe 95% efficient. That's a great thing to do. But if you just left the old flue in place and now your water heater is connected to a flue that was designed for a furnace water heater combination, your flue for the water heater is oversized now. And that water heater may have a hard time heating that flue up in a fast enough fashion. The way flues work, chimneys, you know, they warm up, the stack effect is created within the chimney, exhaust air is pulled out. That's what natural draft chimneys do. And a typical scenario that if you see, and you might say, oh, this could be trouble, is you have your old naturally ventilated water heater next to the brand new high efficiency furnace. And the old water heater, the exhaust goes up and attaches to maybe a 6-inch metal flue. That is a big warning sign right there. Because that water heater now has to heat that whole flue up to be warm enough to get a good draw going. I'm just bringing this up because it's a related issue when you do combustion safety testing. I can't actually simulate that right here. You actually do a separate test that's called spillage. When you have a naturally vented appliance, you actually time how long do the gases spill out into the room before the flue heats up enough that it creates a draw, and now the exhaust gases are leaving. You know, when you see the little white deposits around the top of your water heater, those are created by spillage. That's exhaust gases. It's mineral deposits and rust taking place because your exhaust didn't actually make it out of the building when the water heater started up. It's spilling back into the room. Also, all the carbon monoxide is spilling back into the room. And when you have an abandoned water heater like I'm talking about, it's going to spill for a lot longer because the flue is improperly sized now. Knowledgeable heating contractors know that they are supposed to change the flue. And they will point that out to the homeowner. Changing that flue is going to cost another $500 or something like that. And it's not part of replacing the furnace. So oftentimes homeowners will refuse to pay the extra $500 to have their water heater flue reworked because all they wanted was the new furnace. And according to BPI standards, the heating contractor should say, well, then I won't put the furnace in for you.
Here's a carbon monoxide alarm, right? It's going to annoy you.
If you have a carbon monoxide alarm in the house,
Sure.
I've actually been in houses that have carbon monoxide detectors that I've hit the button to see what the memory says. No, it says that it's been to 29 parts per million, which if it's 30, you have to evacuate the building. But the homeowners had never even heard the thing go off, ever. And we've done studies at homes that actually show where we put air monitors in, and you can see the carbon monoxide levels go like this in the home when people get home. It's especially for attached garages. People get home with the attached garage, they park the car, there's carbon monoxide from the car exhaust. They come in, the furnace goes on, there's a leaky return air. It sucks all the car exhaust from their garage and dumps it into their house. And then you get this big spike of carbon monoxide in the house. And then slowly, over 6 or 7 hours, the breathing of the house through all the joints everywhere settles out the carbon monoxide level, and it gets down to some reasonable level, like 3 parts per million. But that happens all the time, and people don't even know that it's happening, and they may have an alarm that somebody else may have put in, and they don't really even know what that alarm actually means.
Can you change the level on the alarm?
And usually, if you get yes, if you get one that can do that. Most of them, it's just plug in, and it goes off.
You can hardwire them to the other alarms.
Yeah, you can. There are some now that look just like a smoke detector, and they double as a smoke detector and a carbon monoxide detector. Those you can't actually read what the level is or get the history out of or something like that. At my house I only have direct vented appliances, but I still have one, just in case, outside where the bedrooms are, just to know if there's ever a problem.
But putting them on the ceiling isn't the best idea because carbon monoxide usually sinks to the floor.
Right.
And just to throw a term out there, it's usually called an orphaned hot water heater. They get called an orphaned hot water heater because you take away the furnace and they're orphaned in the basement with an oversized duct.
That is the technical term. It's an orphaned water heater. But they're, can really be an issue. Other ones that we don't think about as much that can be issues are really, your fireplaces in the home. We don't think about our living room as a combustion zone, but when you have a fireplace in there, it is a combustion zone. And oftentimes that's right near the kitchen and you just did the fancy kitchen remodel and somebody talked you into putting a 600 CFM range hood in the kitchen, and so that happens to be the day that you're running it because you have people for dinner and you have fire going and you can't just seem to get the flue going very well and you keep backdrafting smoke into the house. At least with the fireplace, you smell wood smoke pretty quickly. It's less of a safety hazard, but we always have to test every combustion safety zone in the house when you're going in to do safety testing. So the other thing I wanted to show you was how these fan effects could pressurize one part of the house differently than another part of the house. So this was the basics around how to do combustion safety testing. You try to find what is the worst condition you could put that part of the house in. And to your point earlier, sometimes that might mean you leave this door open. Sometimes it means you leave the door closed. Sometimes it means you leave that fan on, and sometimes you don't.